Hello, everyone. My practices for the video assignment were the asking questions and defining problems and developing and using models. I found that these two practices to be very interesting because I feel like we do them naturally, at least, especially the asking questions and defining problems. I feel like we do these things very naturally as teachers in the classroom. Um, so for us, just a summary of asking questions and defining problems, it's definitely a very clear progression, and it starts out very simple for students in K2. Let me show you here. In K2, it starts out with asking questions and defining problems, building on prior experiences, and progresses to simple descriptive questions. So this is just real simple, starting out in kindergarten through second grade, just getting them to start asking those questions and being able to see that they can answer questions to problems and being able to see those. But it really much builds on prior experiences. When you move into 3-5, and I'm a third grade teacher, so I'm very familiar with third graders. They start to ask questions, and they're building on prior knowledge, but they're also having this part here where it's what would happen if a variable is changed. We see this a lot in third grade with like forces in motion, and they get to see like if a car is on the top of the hill and the car gets dropped, they can predict what's going to happen, but then they can play with different variables and things like that. So it starts to show that progression. And then in middle school, you'll start to see that they're still asking those questions and defining problems, but they're starting to look at the relationships between variables and clarifying arguments and models. So it just gets a little bit more difficult as it keeps going. So this I thought was interesting too, is asking questions that require sufficient and appropriate empirical evidence to answer. So it's just the type of questions that they get more difficult to answer. Something I saw on a website that I was looking into was that there's a couple different things that teachers do to support this. One of the things was just encouraging and teaching children or the students to create hypothesis and just how to be intuitive and ask those questions. One thing I saw a third grade teacher doing, which I thought was really cool, was she had a question wall. So the question wall was basically like kids would come up with a sticky note and would write a question that they have. It could be about anything. And they would take the sticky note and go and stick it on the wall. And every couple of weeks, she would pull a question or two that she thought were really good, awesome questions. And they would actually do their lessons based on those questions. It was really cool. I think this is also very similar to if you've seen Mystery Doug, which I think is an amazing tool to use in the classroom. Mystery Doug picks kids from around the United States to ask really interesting questions. And then he does an exploration in a video based on that kid's question, which I think is really cool. And I do that in my classroom. One thing I also noticed about this is definitely a cross-curricular practice. We're asking questions in everything that we do in reading and science and social studies. Kids should always be asking questions. And I think it's also interesting too, because the way kids nowadays are getting the answers to their questions is very different, because they, normally you ask a question, you Google it. So it's interesting to teach these kids that what happens when the question can't be answered on Google. My second practice that I was looking into was developing and using models. And I think this is actually really cool to look into. We do this in third grade, for sure. And it starts out in K2, of course. And again, it's the progression. And it starts with just being able to identify what a model is and distinguishing between the model and the actual object. So being able to tell the difference between the two. So it starts very simple, and they get to compare models and things like that, and developing simple, really very, very simple models to use. Then in 3-5, it starts getting a little bit more difficult where they're planning and creating these models. And then they get to add into this word, this one word I see a lot starting in 3rd grade and on is revising. They get to start, they build a model, they revise it, and they make it better, which I think is cool. And then in middle school, it's very similar. It adds into describing and testing the model and predicting. The real change I see here is revising the models, but then it's just more abstract phenomena and designing systems. So it just gets more, what they're designing models for just gets more difficult. I think that this one thing, the word I kept seeing through all of the when I was doing my research on these two things was the word engineering. They're trying to get kids to, or students to move towards these engineering practices and getting kids to be able to come up with new innovative ideas, which I think is really cool. They also, one thing that we do in 3rd grade in my classroom is, again, we did this year, we did a bridge activity using mystery science. And the bridge activity was where they got to create a model of a bridge. And they went through the whole process of, designing the bridge first, drawing it out, creating a blueprint of the bridge. And then they actually made the bridge, a little model of it, and they got to test it out. And something that I notice is very difficult for students when they start doing modeling and trying to troubleshoot these problems is they get frustrated if what their solution doesn't work the first time. That was something we had to have a discussion about in my classroom. Was it's okay if your model doesn't work the first time. It's not always supposed to. I mean, that'd be nice if it works like that all the time, but it doesn't. So it's teaching kids that, okay, it's okay to fail the first time, but then learning from what didn't work from your first model and then being able to pick up and make your second one even better. There was this really cool video I watched where it was a guy who he had a kid draw a picture of something. It was a picture of a butterfly, I think was what it was. And the first picture of a butterfly, he said he gave the kid a picture of a real butterfly and said, okay, draw this. And the first picture was not very good. And the teachers went up to him and he said, okay, what can we do to make this drawing better? And he then he picked out some things. Oh, my wings aren't the same size, or this isn't the same size and stuff. So then he said, okay, go and take those things and apply your changes. And the kid went back and he created a second butterfly. That was definitely a better butterfly than the first one. And then he said, okay, now how can we change this one so it still looks more like the picture? And he's like, oh, well, my wings aren't pointy enough. So then he went back and changed his drawing again until it looked a little bit better. And then he came back to the teacher and they compared this new drawing to the picture that he was supposed to be drawing it to look like. And again, he kept revising to the point where then his final picture of the butterfly was amazing. And it looked very, very much like the picture. And he showed his students in his class the very first butterfly this kid drew to the very last one he drew 5 butterflies later, and how much better they were. And he showed that he showed students that if you can persevere and keep going and keep trying and making things better, then you'll get something amazing, which I thought was a really cool lesson for kids to learn. Overall, the things I noticed with these practices is they're definitely cross-curricular. There's definitely a progression, and it's very easy to incorporate them in your classroom, which I think is really cool. And there's lots of resources out there to use them. Mystery Doug is an amazing one, and Mystery Science has been one that they incorporate these practices quite a bit. I think that's it. Thank you.